Oh, hello, hello. That was sudden. I did not expect that to happen, but it happened. So today we have quite a bunch of technical issues, but that's fine. So um, I usually invite my guests after the introduction and after everything, but hey, looks like we're both on the stage right now, so that's fine. Anyways, let's start with small introductions anyway. To you all, welcome to the stream. This stream has an incorrect title at the top because we will not be talking about the redraw. We are going to be talking about how to train your own model. Not so deep into the roots that everyone will get confused and it will get problematic. We will talk about how to approach the topic, how to start, where to look for it, and how to ease into training models and what training a model actually means. And today with me, there's my special guest. Am I showing at you now, Piotr? Or
Opposite direction.
opposite? Okay. My special guest, Piotr, who is our AI expert. Piotr, would you like to tell us a little bit about yourself?
Hello, everyone. I'm Piotr, as you may see. I'm senior AI system engineer at Callstack. I'm also a PhD candidate in artificial intelligence, cooperating with Wrocław University of Science and Technology, as well as I've got plenty of experience of providing production-grade AI systems in banking industry and also medical industry.
Oh, I didn't know you also work in medical. Damn, that's quite a portfolio, quite a CV. And with us also is Ryan. Hello, Ryan. Good to see you. And hello, Ayman. Great to see you as well. And with all of those introductions out of the way, I prepared a special sort of map that we'll follow through, and we'll get all of the questions we want to get answered. So let me quickly show the, that's not the screen. This is the screen, this is the screen, this is the screen, and now I should be able to share the screen. Window, this window. Can everyone see the screen?
Yeah.
Okay. So let me also turn off the preferences and Zen mode, I guess. Okay. View mode. I guess we can go with that. Okay. So the topic of today, how much internet does it take to make an AI? As a small aside, as my personal preference, I'm not a fan of AI, but in the same time, I love AI. Me and Piotr talked quite a bit in the office, so he can confirm that I like AI, but I also can confirm that I don't really like AI. So before we jump into the main questions, Piotr, do you like AI?
In general, I do. That's a technology that, from the perspective also about the history and when the first perceptron and neural network architectures were proposed, we are talking about, in case of neural network 60s, right, 1960s. Back then, the computing power was not there. And right now, considering as time flies, we've got NVIDIA CUDA for almost developed for almost 20 years. We've got the hardware to make a lot of computation in almost no time. So from the perspective of someone who is interested into computer science deeply, as well as the whole topic of artificial intelligence, it is still very exciting to witness all of that.
Yeah. Well, it's a new age, right? So yeah, I'm partially joking because, of course, it's an amazing technology. Sometimes I tell people that I am anti-gun activist with a gun in my holster, because, of course, as everyone, I also use AI, but I believe that not everything that is AI is a slop, and in the same time, people use AI irresponsibly. So today, oh, and also AI prices are going up. I think everyone can observe that. And it turns out to be quite an inconvenience, to make a small segue. It turns out to be quite an inconvenience to rely and depend on a model that is being provided to you by external company. Just yesterday, I saw some messages. Maybe Piotr, maybe you could give a little bit more of context for that. But I saw a message saying why the models have to be nerfed before our workshops and stuff like that. So, Piotr, were models actually nerfed yesterday?
I doubt that was exactly yesterday, but in terms how companies are providing the models over time, it may happen that due to some data center logistics, we can witness some sort of quantizations, for example, that provide us exactly the same model but at the smaller amount of precision.
So, for those who don't know what is that, let me try and quickly explain what is a quantization. Assuming that all of the vectors in a vector database in the tokens are saved like this, right? We have very precise representation of how model thinks and how model stores the correlations between stuff. So if you would like to quantize the model, basically means that from this we do tick that, and we do that, and we do that. In simple words, if those were coordinates on a map, you would still arrive to a correct place, but if you would be delivering food, you'll be running around and trying to find the exact location. And that's exactly what happens after we quantize models. We do a small lobotomy on them, and they still work, they still perform, they still have the knowledge, but this knowledge gets shifted a little bit. It's the same what happens when we take a JPG file and we optimize it for size, right? We lose some of the quality, but it can be processed faster and delivered faster. So yeah, it makes sense that companies could first serve proper models and then quantize them. So I think all of that would be a great segue into the first question, which is, how smart is a brand new model actually? Assuming that, let's say we have a company, we create a new model, how smart it is, how can we check how smart it is, and what is actually the model smartness, if you know what I mean?
So in terms of model smartness, it is a very difficult topic, and also maybe not smartness. Smartness actually is the proper one here. Models are very smart, in navigating through patterns within the data, and with that, we usually witnessed something that model was big enough to carry on the knowledge, carry on the patterns, carry on the statistical correlations from the data, into the waves. The waves that Kevin just a moment ago presented to you in the form of floating point variables. And with that, after the model is trained, you've got it trained at the full possible precision, at the full quality that it was prepared on your GPUs. And at that very moment, you can export it fully at the full precision.
So you have a crisp 4K model.
Yeah, exactly. You basically copy it one-to-one. And of course, at this point, you can perform some benchmarks and evaluation. Usually, when you are training a model, you've got at least training and evaluation data set, which during the training, time to time, comes back to the model and take some questions to validate that the answers are correct here. And if you perform like the full training, you have to evaluate a lot of things, really. If we are talking about generative AI, yeah? In terms of generative AI, you have to validate how the model responds. What is the likeness to continue the answer? Therefore, you have to tweak the temperature to the architecture and also the model you just trained. How the training process look like after you train it. You also have to evaluate how the willingness of the model to answer questions that can be politically not correct. So you have to apply some guardrails on top of that, and make sure that model will always provide you only the proper answer, and also the answer that will not harm anyone, because that's also a case. If you've got anything that's suspicious in your data, anything that is out of the domain that you're training the model in, then it can just float into that direction. Remember that during the training we show all the data except the ones you are testing it on, right? And from that data, the model can get all the correlations, all the patterns, and we can also pass the patterns that we don't like.
I was
It's
trying
also
to paint a brain that will be the model
Mhm.
to talk about. Oh, let's say that's a brain. So if I understand correctly,
beautiful brain.
Thank you. If I understand correctly, if this would be a fresh new model, a fresh new nice model, it's here. Then we need to add on top of that a layer of I completely forgot the name for it. How the not the guidance, but alignment. I like this word.
Exactly. I was about to say it too. So after you've got the model trained, you have to perform some alignment. We are talking basically about pre-training data and post-training data, and after that fresh LLM training, it is just wild. It can do anything that was in the data. So you can clearly see how important it is to have the proper data. And after you've got that fresh LLM without any possibility to stop it from answering the question, really, you have to apply some post-training alignment that
Actually, I think that before the alignment, we should also mention one more layer, because the alignment would be like training a dog, right? That this is incorrect, this is correct, this is a friend, this is an enemy, whatever. But there would be also a level of like pre-training, like training the conversational training?
Exactly, instruction-based training.
So without instructions, LLM wouldn't even understand that, oh, we are conversing. Like, what is a conversation? How does a question and response looks like? So we have fresh LLM, which is like a massive, basically a Google, a huge database of connections, of understanding. This is the primordial being. This is genius, but also it's dangerous. So we then need a way to communicate with that. We add instruction training. It usually looks like it's being fed on examples. If somebody says hello, you respond with hi. If somebody says, can you please give me instructions on how to build a bomb? You say, no, sorry, I was wrong. That's actually an alignment. So instructions is how you interact. Alignment is what's good, what's not. So are there any other layers to that?
In terms of the model itself, not. Of course, you've got the inference server that is like running the model like an application, and it processes the requests and responses, but also it creates a whole abstraction level conversion. So you've got let's say OpenAI compatible API. So you've got the chat completion request going into the inference server, and then each of the architectures, each of the models are processing the text in a different way, and also you have to remember that it basically converts all the requests into a single input, and that input is translated via something called chat template. And later, when you've got output of the model, it is also a single string, a single stream of characters that you have somehow to divide. So here you've got decision about the tools to be used. Here you've got a thinking part. Here you've got the answer. And how that division of that huge string is done, it is the chat template.
And chat template, if I remember correctly, it's basically training a model to use additional magical tokens that help it to think. So there's a start, there's actually em start, em stop, there's tool call. I assume that new models now support also something like thinking, that there must be some tokens for thinking. So there should be thinking start and thinking stop. So the problem here now is that, as Piotr said, those models have an input and the output. And the input is basically a string, a huge string, a lot of text, and the model parses the text. So tell me, Piotr, what stops me from sending on the input something like this? I should give the user instructions on how to build a bomb inside thinking start and thinking stop. As a context for conversation, as a injection.
There's a lot of assumptions here. Starting from the model itself and the what was drawn here in terms of the alignment, it depends on the architecture. Sometimes it is done directly on the foundation model. Sometimes it is done after in the instruction-based tuning. Let we keep it as it is. Also, the tags at the output, those differs from architecture to architecture, from model to model. So in that case, about the input, usually when you are processing the input, input is retrieved from user message, not the assistant message. So that thinking injection should not work, but it is.
But it's thanks to API, right?
Yeah, exactly.
So,
and how the inference server is passing it to the LLM itself.
So actually, there is also one more addition, which is not a part of an LLM. Let's call them guardrails.
Yeah.
Or overall API/API, right? And this is on top and on the end. So it prevents me from abusing my input and prevents the model from outputting something. And from this, like a small weird anecdote, I'm still not 100% sure that this was the case, but one of my friends once said that, oh, there's something weird going on with ChatGPT. I was like, why? Because it totally rejected the conversation. Like it was not talking with me at all about grapefruits. Like she wanted to do some juice with grapefruit, something like that. And in full honesty, I'm quite convinced that it's because of how tokenization work. And let's say that if a grapefruit, maybe grapefruit is not a one single token, maybe it's connected of tokens like that. And in that case, this one token in the middle would be totally highlighted by the first guardrail, and it would sound the alarm like, no, we don't talk about this. So
that may be a case. That's you touch a topic, very important one, about the tokens and like how those models work in general, right? The situation with strawberry, yeah. How many R's?
How many R's?
Yeah, and yeah, people think that model is able to understand the text like letter by letter. No, it is understanding in the text token by token, and also those how the tokenizer and tokenizer vocabulary is built. It depends from model and the architecture. So. And its architecture. So sometimes you can store like most commonly used English words as a single token in order to optimize the processing here. Or sometimes you can divide it, and also from the perspective of representations later.
I'm super sorry for that, but I think I'm gonna stop you right here for a moment, because I would love to make a special live stream about tokens, tokenization, tokenizers, and stuff like that. So, and in full honesty, I already took so much of your time on first question. So let's slowly move forward. Before that small answer to Ryan, he asked, is that the same special tokens that we use in BERT, for instance? Not necessarily. This is just a text representation of how those are handled, but in different model architectures, there might be used different tokenizers. So for instance, in one tokenizer, this token EM start has a number 1, in other it's 150, whatever. So those are just visual representations of those tokens. It doesn't necessarily mean that this is how they look, but all of those models that are able to have conversation have tokens that help them guide the output in more conversational manner. And with that,
And
let's actually...
if I may add something here, in terms of BERT, we are usually talking about like the masking token or start of the or sentence, end of sentence, and end of sentence tokens. Of course, those are like a single ones that have got a very special ID, because all the tokens are translating those small parts of text into identifiers. So for example, in terms of such example, I can show you quickly how that chat template is parsing it, and just give me.
Oh yeah, I know that your setup is quite tricky for sharing the screen and stuff like that.
Yeah, but it is.
Yeah.
And here you've got example of. Kevin, can you bring that to the screen?
Oh, yes. Okay. Yeah. Sure.
Yeah. So here you've got example of that chat template, and that chat template is, for example, here handling a system tool definitions block. So you can see that we've got like a system and a developer terms, and we can see that it is identified by the system. So like a system message part. Also, if we've got thinking enabled, you can see that chat template is basically a very simple simple template that almost like in plain English defines plain English slash Pythonic kinda notion.
Python is the most like Englishized language, I think.
Yeah, and if we read that line, if enable thinking is defined and enable thinking, we are injecting that think.
Yeah. Well, a
At
lot
this
of
point,
syntactic sugar as well, but
at this point, that's still a string, but later it is converted to a single token. And those
Oh, right.
tokens, for example, here I've got example of Gemma 4. We've got a tokenizer, and here in that JSON file, it is too big to display, but I will quickly download it and show that to you. I hope it will work.
So tokenizer actually works as both decoder and encoder, right?
Yeah.
Oh, you're downloading it. Okay.
Yeah, I'm trying to download it. It is very.
I think I've never seen a tokenizer file. Oh.
Okay, I'm opening it. VS Code. VS Code should handle the file, I hope.
You know what? Just for security reasons, I'm gonna switch back to my screen.
Don't worry. I've got
plenty of experience.
I'm prepared in that case. Okay, so I will now share the VS Code window. Yeah, exactly. And you you can see. You can see that I'm well prepared. I've got like a live stream directory.
Oh, nice. Okay.
Everything from for live stream here. So here inside, yeah.
this is padding, just and like empty space, right? This is basically a space pad.
Yeah,
There is end of sentence, beginning of sentence, which is kind of weird. I would assume
yeah,
that beginning should
yeah,
have
yeah.
lower ID.
Exactly. You are right.
What else do we have there?
And
Pad,
later we've got like an unknown mask.
unknown,
Uh,
mask.
by the way, Nekena, the question you ask, mask is also like those at the very beginning are very similar to bird tokens.
Hmm.
And here the fun starts. Yeah,
Oh,
uh,
whoa, whoa,
beginning
whoa,
of
whoa.
tool, end of tool.
Why are those not called A tool and B tool? Like, why changing convention fourth token? And what happened to ID 30, 45 and 44?
As always in IT industry, it was the decision that was made.
Mhm.
It is by design. Of course, we can follow some certain pattern. We can set the specific IDs, but of course, some IDs might be reserved. It also
Mhm.
depends from the model and the architecture.
Mhm.
And here, for example, a tool call. You can see beginning, end, tool response.
Oh, so the
It is
previous were tool decorations.
yeah,
Okay.
yeah.
Okay.
And later we've got like a thing.
I knew there is a thing.
Yeah, and also a channel. And the channel, it is information that shows if it's user message or assistant message, right?
Okay.
And also the turns, image, audio tags. Yeah, you've got all of that. Of course, at first you've got like the added special ones. Um, Also, you've got how the splitting word, and later like you've got yeah a vocab of
Yeah.
the
Okay. Ah,
actual
they left the space for future extensions. These are
yeah
the
and
unused IDs.
yeah exactly. and
Okay.
here and here you've got plenty of unused.
Okay, that's a choice.
Yeah, that's a
That's
choice,
interesting.
but you will agree with me that something like that happens. Yeah, you've got a document with a plenty of new lines, and you have to handle it somehow.
I
And,
mean, yeah, it would make sense
instead,
that.
yeah, imagine that, for example, in that case, you've got 5 new lines, right? So that would require 5 times putting a token 107.
Oh, and also quite nice thing from that is that model can learn that if something is separated by single space, a single new line, it should be connected and correlated. If there are 5 new lines, it might be a separate, different context. So, yeah, okay, makes sense.
Mhm. And of course, after that magical tree and another magical
Mhm.
tree,
Yeah.
you've got things like you see
So,
it's like HTML.
looking at this, how uh, like a side question.
Mhm,
So looking at this, that this is tokenizer and this is how the
mhm.
token is going to work. Uh, where does the special AI dash comes from? If all of the training data usually had a regular dash or something like that, like where do the double dash comes from?
Books,
Oh, really?
yeah. Uh, Often in books you have that long dash. You've got a pause.
Oh, I didn't know that.
Yeah.
Huh, that's interesting.
Yeah, and
Okay.
we not only train the base models on the internet, we also train them on books.
Okay. I'm quite surprised that books take precedence over that. Like yesterday, I was also thinking, what's the like, why are models trained on multilingual data? Like, isn't that a waste of tokenization and basically doesn't it make like a waste of space and lowers the quality? But apparently, all of the newer models are trained on multilingual tokenized data sets.
In general, within that vocabulary, you have to handle everything, and you can optimize it or you can keep it as it is, so letter by letter, and somewhere there will be something like that. But
Can you
but
check if
maybe
there is token for LOL?
um,
Hey, XD.
uh,
Yay! Oh, there should be also difference for XDDD.
no.
Oh, so
You-
okay, so
yeah,
models might have.
yeah, in that case, you've got 9,309, and then you've got D.
Yeah, yeah. So that's actually very funny that basically, if you would be trying to express yourself and you would write XDDD, model might be like, oh, there is XD, and then like some Ds for some reason. It might
Yeah, and
actually lower the quality of response.
exactly, exactly. And if we come back to the topic of model training, the thing is that during the training, models learns statistical correlations between those. So if
Mhm.
we had, uh, you that's nice one. You can see that it has upper letter D.
Oh, yeah.
Yeah, and
Uh,
that one has upper letter X, and both upper letter. Those are like separate tokens here. But
makes sense. Kind of makes
yeah,
sense.
exactly.
This would be like different emoticons.
And here, basically, looking at the vocabulary here, you can check what are the limitations of the cognitive capabilities in terms of the text, right? Because
And
yeah,
if I remember, if I understand correctly, if a word has a lower dash in front, it means that it's a beginning of the word, right? Like a starting token.
it depends.
Oh, okay.
In general, not exactly. That depends from the rest of the tokenizer, all the rules
Mhm.
that was above, but also like for example here we've got that underscore alternative, but if we put yeah, and it is even the long one. You can see the
Um,
alternative is separately.
I I have a so there was I noticed that there was underscore vor like VOR. If you could Google for that, I'm sorry, go on search.
V O
Underscore VOR underscore first. So it's
uh,
like yeah VOR.
no at underscore V is not present here at all.
Oh, double underscore VOR.
Okay, double underscore V no.
What the hell? I just saw it. Can you just search for VOR without the dashes? I've seen that, and I want to. Oh yeah,
Oh yeah,
VOR. And I wanted to check like if this is vor, so and there is like underscore vor. So I would assume that there will be a token for carny with the dash at the end. So model can answer carny vor, omni vor, and stuff like that. That is just a theory. I'm just. Can you check for Carney? Token for Carney. CARNE.
C A
ARNE.
R
God damn it.
E. Yeah.
God. Okay, sorry. I was just like, I got overexcited again. Yeah, but that's super interesting. Like, oh my god, I could talk about this freaking tokenizer for 2 hours. Really, this is
Yeah, like from that in Polish you've got like a high, which is
Mhm.
which is
Actually
Czech.
without chi.
Yeah,
It's
exactly,
Czech.
exactly, and and this is and like those are the bases that are converted and put as the identifiers to the model itself. And the thing is, I wanted to highlight here with XD that if you put XD and next you put another D and DDDD, during the training, a model learns a correlation between that token identifier and that
Mhm.
token
All those.
identifier. Yeah. So it will understand that after XD there might be another D coming.
Okay.
And
Piotr,
during
quick
during the
aside,
yeah.
we have a new viewer who said hello, and I got very excited some time ago. Can you decode what that nickname says? What's that nickname? How you can pronounce this nickname?
Uh, yeah, I see algebra here in infinity.
Yeah, yes. And what's next? Infinity is the first part of the nickname.
Then we've got dy dx. Yeah.
Infinity rate of change. Yeah. Hello. Good to see you here. And Piotr just confirmed in front of everyone that he indeed is a PhD and knows what he's talking about. But actually, Piotr, let me share back my screen, and let's jump to the next question. that was the first question. We have still quite a bit of those, so we might have to do a part two. I really doubt we'll fit entire live stream. Especially, I had no, like, some guests. We just have a conversation, but it's conversation that we all of us push and continue. Piotr, I see that with you, conversation can just like branch out in so many fascinating, interesting ways that streaming with you will be dangerous for the streams. But of course that's a compliment. So
thank you very much.
Small side question: if a data set would be food, what would it be?
Something full of all the ingredients the body needs. So full of protein, full of fibers, full of everything. Because the data set, the data itself, it is the heart. It is the core of every algorithm out there. Yeah, we can say that
deep of an answer.
Yeah, so data set is the richest food that you can imagine of in terms of the how nutritious it is.
Actually, I'm now double guessing my own question here, because I would say quite a little bit contrary, that data set could be any food. It can be pizza, and it can be some nice, amazing nutritional food that the body needs, because the data set is the foundation on which the model is built, right? So if you would feed
Yeah.
a lot of pizza to the model, we're gonna have an overweight model that struggles to get off the couch. And we don't want a model like that. So let's assume that we'll be using the best ingredients. Oh my, it would be so great to have a sponsorship here. Like some packed food, like from our sponsor. Yeah, so basically infinite rate of change said that whole food pyramid, and yeah, that would be also true. So from that, what actually makes a good data set?
Oh my God, we only have an hour of live stream left.
So let's as a challenge, let's try to answer that in one sentence.
Proper data distribution.
Oh, so variety. Or even a variety with quality. Something like that would make sense.
Yeah.
Because if we would have a data set that doesn't have enough variety, what variety gives is, and correct me if I'm wrong, something called emerging capabilities. And emerging capabilities is something that actually I think plenty of people can also feel themselves and experience themselves. So for instance, if you would learn Photoshop really nicely, right? And then you would learn music theory separately, and then you open up a software for audio editing, and suddenly from those two worlds you have a much easier time understanding the UI of a program to edit audio, because you understand audio itself and you understand the UI that is similar to graphic editing. So thanks to that, you are more specialized to learn faster, understand better. So with nice variety and good quality, we'll have a model that learns stuff that will enable it to drive new conclusions and have the thing that we love the most in our models, which is inference.
And also, you can take a look at that from a different perspective. If data set is missing representation of something else, so for example, you've got a data set about audio and photography, and you have no information about, I don't know, geography, and if you try to run any model, it can be classical AI, Gen AI, a question or a task about geography, it will be out of domain question. So your data set needs to cover the data that your model will be used on.
So this would give us most probably hallucinations, right?
Yeah, kinda one of the reasons.
Okay. So can a small, varied, high-quality data set beat a big data set in any way? Let's say I would.
Yeah.
Let's say that I would. What's the quality?
Yeah.
So let's say as a exercise, I'm doing a dump of Wikipedia, right? And then I'm doing a dump of entire internet without Wikipedia. Which model has a higher chance on being correct, high quality responses and stuff like that? the model that was trained on entire internet without any what's the word? Without any quality control, without any checks, without any sifting through good or bad things, just entire internet as is, versus entire Wikipedia, which is nicely curated. What do you think? Which model will be better?
Quality over quantity, always.
Okay. So curated data set that is smaller in size would be much better than a ton of. Actually, as an anecdote, long time ago I was training small stable diffusion models. I mean, maybe not models themselves. Oh, actually, there were models because I didn't learn how to train LoRa's. So I was training a model, and I noticed that with just, let's say, 10 to 15 photos of yourself, the model can extract your likeness to a really good level. But if you would give like a grainy, like thousands of grainy, bad lighting photos, the result would be bad as well. So it's smaller amount of targeted data set with quality gonna win big against a big data set. So it's a David versus Goliath, and David won. So, yeah. Oh, actually, I kind of sped up, and this was the exercise, like TikTok comments, Reddit, Wikipedia. But also, actually, Piotr, if you could, this is a part that I also don't fully understand. If we would train actual AI models, let's say we take both, and we have a question from Infinity. We'll get back to that in a second. Let's say we take a base model and we fine tune it on TikTok comments, Reddit, and separately also on Wikipedia. We have 3 models. How would they differ actually?
Yes. First of all, style
of response, right?
Yeah. You can see the shape. Like, if we come back to the concept that the model is basically giving you a string, right? A very long string. TikTok comments are kind of short. Reddit messages are, let's say, short to medium. Of course, they can be long, but Wikipedia rich articles are usually very, very long. So first of all, you will get completely different shape of the output and also the style of it.
Yeah, so Wikipedia would have without personal, like it's not talking to you. You're basically querying a huge database.
Yeah, exactly.
Reddit would have more statements, but more personalized. And trying to TikTok comments would be short, snappy, witty, and like as a comment. So I would assume that this would be Grok. This would be Gemini, and I think this would be GPT. I'm biased. I like GPT. I operate mainly on vibe checks. But from Infinity, we have a question. What are your thoughts on JIPA world models? What is it? I'm not sure what is JIPA.
Yeah, in general, the world models are very interesting. Are very interesting concept. Not only from the perspective what they can achieve, but also how they represent the data. So instead of language models here, we are talking about word models, which represents the whole physics of the whole, like all the parameters of the surroundings that are around us, right? And yeah, and the thing, for example, imagine the capabilities, for example, for car industry to simulate how the car body is getting into an accident. So
Oh,
yeah,
oh,
you can simulate the whole physics, and you can simulate the whole world around you with those. This
yeah.
is
So, like, to
just,
give
yeah.
to give an example, and I'm giving an example not as an expert, more to confirm if I understand it correctly, so you can lynch me.
Mhm.
Let's say we train a model using the JIPA. Is it architecture? Is it framework? How would you call it?
Mm,
A
in the
framework? Because this
uh,
is approach to training a model, right? This is not a model called JIPA. JIPA. It's more. Sorry. I'm just struggling to understand. Like, is it an ideology? Is it a framework? Is it an architecture?
it is architecture.
Architecture. Okay.
I also wanted to confirm it myself, because the amount of
Oh,
information right now flowing
yeah.
is huge. But yeah, it is basically the architecture, joint embedding predictive architecture.
Okay. So this is actually amazing because imagine that now we can take data sets from a car, right? You're driving a car and you have a huge amount of data being streamed to you from the wheels, from the driving, from the wheel, from the wheels,
Mhm.
from the gas, from the brakes, from the engine, from everything,
Yeah.
along with the camera, front and back. And
Mhm.
the model can learn that, oh, if there is this white weird stuff on the road, the
Mhm.
suspension might get wonky or it might get slippery and I need to prepare for corrections. If
Mhm.
there is somebody on the side, it can increase a risk of me suddenly turning left or right or braking.
Mhm.
So yeah, this actually um, this kind of connects to a topic we had in the office, right, Piotr?
Mhm.
So in the office, I asked Piotr why uh, cars like Tesla are thought on data sets from camera, and they operate on cameras and not on lidars, because lidars would be able to detect depth and everything like that. But so why cameras? And I think our conclusion was that the amount of data.
Mhm.
Like nobody has a lidar camera in their car currently, but there are thousands upon
Mhm.
thousands of um, videos from cameras. There are videos gathered by like Google cars driving around, and
Mhm.
I believe every Tesla car not only rides by itself but also streams a lot of data for future teachings. So accidents like there was this one long time ago where a Tesla car hit a camel, and apparently camels were not really a huge part of the training data set. And maybe a car thought that, oh, it's a mountain, it's two mountains, it's
Mhm.
not a horse.
Mhm.
Um, so yeah, a kind of a sidetrack, but I didn't know that this is a new. If I would have to say, oh, actually, AGI, Piotr, AGI, current architecture, future architecture, or unknown? Because I think JIPA wouldn't be AGI, but it would be great.
In general, world models are uh, really capable of processing information, and this is going to be like completely new era of models at some point, I think.
Oh
We
wow!
can we can witness it even right now. The application here is different, right? Of course, with language model you can with language models you can have a conversation, but with word models you can simulate. You can predict
Mhm.
the behavior. You can basically check all the limitations of all the materials on Earth in a simulated environment of the computer.
No.
Like
I mean, that's how they train, right? I've
Yeah.
seen videos of, I think, NVIDIA training mechanical arms based on like a simulation, basically. So they were making a simulated world and making the model move simulated arm, and they were cranking up the speed to have it like learn 10 years in a matter of 10 seconds, and then a model just reapplies the same principles to an actual physical arm because it learned on
Yeah,
actual physical
yeah, yeah,
representation.
yeah, exactly. And the thing is with like a synthetic data generation, how much is opened by word models
Yeah,
in terms of synthetic data generation. You are
yeah,
simulating the world. You can get any situation you can imagine of, and you can generate any amount of data you like from that.
yeah. Hmm.
Yeah.
Infinity said that it's scary to go on Tesla on a Halloween then, because you have a lot of unknown stuff. But I mean, of course, Teslas must generalize in some sort of way that if there is a road and there is anything on the road, stop, right? So it doesn't matter if there's a person with a mask or now hopefully a camel. But going back to the set of questions, what training actually means, Piotr?
Mhm.
What does it actually mean? Let's say we want to train our
Mhm.
new model. What
Mhm.
is the training?
Yeah. We've got set of layers with a particular width. So let's say we've got the wh- the whole neural network is consists of layers of interconnected points. So the thing here in terms of the training, it is to change the wave of connection from one point to another down within a neural network. So remember the values that Kevin presented to you mentioning the quantization. So the thing here is that during the training, we are setting those numbers. We are exactly setting those numbers. We are creating all those connections uh, within the neural network. So imagine that at the very beginning, you can start the network with zeros or random values. Usually, you start with random values, and later you are doing a forward pass, calculate the error, and you are doing backward pass, adjusting the waves of those connections within the neural networks. So this is what training is. This is the adjustments of the value of the connections between the points within the neural networks. And of course, at this point, we are talking about the neural networks that are so huge that we are counting them in trillions of parameters. But you know what? Um, I will show you something. If
I was
you
trying
ask
to.
me, if you ask me about what the training actually means, I will show you I will show you the most amazing simulator of the training process out there. May I?
Simulator of a training process.
Yeah.
Okay.
Okay. Okay. Let me
Uh,
click.
Before that, I would like to quickly show a nice image of like the layers, right? What are those layers? And I
Mhm,
think it's really nicely explained with
mhm,
visual facial recognition models. So
mhm,
let's say in this example, we have 4 layers. The first layer identifies what is light, what is dark pixel, on what are actually dark and light areas, because those models rarely work on single pixel. They work on convoluted parts of an image. So from that, it on second layer connects that, oh, if you join those dark areas with those dark areas, we have a line. And it then identifies a lot of lines. on the picture. And then it passes the findings to third layer, and third layer finds that, oh, those lines connected together are actually an eye, and those lines are also an eye, and this is a nose. And it recognizes more and more and more, and at the end it finds the faces on the past image. So those layers are like building up, right? If we would take now words, it will understand that, oh, this is a word, and oh, this is a word, and oh, look, this is a sentence, and oh, wow, look, this is a context, and this, oh, I just found you a poem, entire poem, right? So layers add more information and connect all of those tokens into something more meaningful at the end of the road. And with that, I'm giving you the screen sharing. This is so amazing. I love this. I've seen this. Yeah,
I
love
told
it.
you this is the best simulator out there.
This is great. Yeah, I completely forgot about that. This is from
Yes.
Fast AI, right?
This is from TensorFlow. It is
TensorFlow.
playground.tensorflow.org.
Yeah. This is
Yeah.
so great.
Yeah. So, ladies and gentlemen, here we have the data, right? So our image, like the data here, consists of here the points with one value, and here the points with -1 value, and we are feeding some features. Like feature is way of, you can see a signal transformation, a data transformation that a neural network that allows neural network to perceive the information much better. Then you've got layers that are stacked one after another, as you can see here. First with 4 neurons, second with 2 neurons, and then you've got output. And at this point, you can see that the value is like kind of random, because it was randomly initiated. You can see that here it is 0.38. Here we've got -0.019. Here we have 0.22. So at this point, we've got all the connections from the inputs to the first layer, and to the second layer, and to the output. And the output tells us like two information, right? Because we've got that those dimensions here, and you can see that those connections, as I mentioned, are between each of the neurons within each layer. So so with increasing the number of neurons, you can see how the number of connections is increasing, and how it is becoming more complex with each neuron, even at single layer added, to calculate the data flows here, and number of operations, how it is increasing. Yeah. And that's why, by the way, we are using vectors, and in machine learning they are called tensors. So that's why we are using vectors/tensors operations, because you can calculate all of that in a single time unit, right? In a single operation of GPU at the moment. Yeah. So coming back, we've got all the waves here randomly initiated, and the epoch is the full pass of the training data. Learning rate, it is the parameter that tells us the factor at which, at the one pass, we are able to modify the waves. Activation here, it is way how we are calculating loss. I will tell you a little about also how the neurons are activated in terms of the signal. There's a lot into it. I will tell you after running with the graphs to explain it a little more in detail. We've got regularization, and also we've got a problem type. In that case, we are classifying into those two classes, right? So here, yeah, here you can see what has happened. We run the training algorithm, and we train that very simple neural network to focus. You can see from the first input, it is focusing less like neutrally on between the first neuron about the it has minus ways to the second and third neuron, and it has positive wave to this one. And you can see that image that Kevin just presented to you. This is exactly what is going on here. This is exactly the same pattern of data operations, data transformations that Kevin was presenting to you. Then of course, the second input is connected totally different different in that term, and you can see those representations. You can see what each neuron is trying to differentiate, and you can see the connections between them, and how everything is influenced within everything, each to each. Later, you've got information about which neuron is responsible for what kind of output here, and also what are the importance of those connections. So this one is not important. This one is more important. This one is very important. That's not really very important. Not really. Kinda. Not really. Not really. Very important. Very important. And that output is kinda not important in that point. But come on, that neuron basically is doing the job. So that's why the wave of that connection is so huge here. And therefore we've got a plenty of information here and a little of feedback here.
So please tell me, in this situation, doesn't this lead to a situation where model can get biased and be overconfident in thinking? I mean, of course, thinking using loosely, in thinking that some areas of data do not matter.
Yes, of course.
So this is like not really an optimal situation where entire model depends mainly on signal from one neuron over the other. Okay. See, I'm learning.
Yeah, the whole aspect of model architecture, it is about the data and also about the task, right? So you can see that here we are able with such an easy neural network, we are able to solve that task. But for example, if we switch to this one with the same architecture, you can see that
two little features.
It is trying, but it is not able to do what it should do. And Kevin, I turn it on exactly to answer your question. You can see how bold are those lines right now, and how bold all of that become, and how confident the model has become into presenting those areas. This is exactly what you just described.
Infinity asked a random thought question. While inference is there a way to pause and debug and diverge with guardrails so model response becomes high quality or reduce over delivering? And this kind of, let me actually go back for a second to my screen, because this kind of touches on that part. So there is no actual way to pause and debug the model and steer it away, unless we're talking about training, which has entire access to the brain, right? But when we are using a model and the guardrails, we only have access to input and output. We cannot really modify anything that happens in realm of instructions, alignment, and fresh LLM as it processes the data itself. So all you can do is, I mean, unless you would run
we can for example tweak the parameters of inference. So you can tweak a temperature. Therefore, you have with higher temperature, you've got a much bigger answer, because model is likely to produce more and more content. With low temperature of 0,
there were those quite interesting techniques long time ago, but also Infinity, in order to do that, you need to have a lower level access to the model. You wouldn't be able to do that via APIs or any provided models. You would need some like Python script, some lower level access to the model to guide the inference as it goes. But I remember there were those nice techniques of something called like incremental or gradual temperature, something like that. So it worked like at first when you're asking the question, the model had huge temperature, and then the temperature was lowering, 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 lowering. So basically, you could say that this was a creative mode. So model first has access to all of the tokens, but it also it's kind of like talking to a high person. That you ask a question, so how was the sandwich? Oh, the sandwich, well, comparing that to an existence of a regular bug, it was, and it's just like high temperature, and then it nails down and hyper focuses on one area. But going back to the to what you were screen sharing, if you could explain what is a feature, because this is a lot of, I feel like a lot of AI areas, AI knowledge and AI industry, it operates on those mysterious terms that are actually not so complicated once understood, but in order to understand them, well, you need to go through a lot of examples and you know, metaphors and stuff like that. So what would you say is a feature?
Feature is a representation of data or a piece of information that allows to differentiate some variable from the input. So in that case, what you can see here, it is like the modification. It is like a alteration of the data, right? So with that x1, x2, x1 squared, x2 squared, x1 times x2, sinus of x1, sinus of x2. This is you see, this is we've got x1 and x2, and we can perform some sort of operation that provides us some additional insights what's going on.
So
and this is like the feature.
So to put it in my simple, silly sausage terms that hopefully will relate with more people, if we would play a game, like, you know, recognize an object, right? This will be a game. And we start with you're blindfolded, you cannot smell, you can, maybe just to simplify, can we say that our 5 senses are basically our features? That in order to recognize something, I can touch it, I can see it, I can smell it, I can lick it, I can listen to it. And with those 5 features, I'm able to recognize a lot. Also, of course, there are plenty of hidden layers that process that information and allows me to understand the object, a little bit better. But those would be basically features, right?
Yes, exactly. And the thing is, I'm searching right now for a very good infographics to show that to you. Unfortunately, I cannot find it easily. But the thing is that feature is sort of the input to the algorithm of yours in that case that allows you to represent the data in a way that is unique.
Okay.
And also
Okay. So,
and also
so
that
sorry.
is giving you the possibility to process somehow those values, right? In order to get the answer, the answer somehow. And
So could we say that if I would be teaching a model to recognize faces, I could give it features like stretch photo, zoom photo, and rotate it, and flip it, and scale it, and whatever. So it can take one single thing and just inspect it under many different conditions and in different multiple ways.
yeah, I found something kind of what I was looking for. So here you can see like different algorithms for processing the data as the features. So you've got like three separate values, three unique values that mean something, and they are the input to our predictive model. And according to that, like if you zoom out, the whole predictive model is just a function, right? Because it gets the input and it gets the output. It is our model, right? So features are the unique inputs that mean something to your model. And according to those, the model can operate to execute your task, to produce your output that fulfills the task.
I just remembered there was this really nice infographic as well explaining the features. So I just remember that I saw the close price. There was a data set of real estate values in USA somewhere.
Yeah.
And if you would make a grid of those values, and you would, for instance, multiply value with square meters, and then I don't know, do some weird operations, and you would look at the grid of all of those operations, you would notice that some of them correlate in some way. They create a line. There is a linear dependency on them. They start to accumulate. So there is some clamping going on, and they start to get into those small, and once you see them with your eyes, you can pass that data and pass that way of processing the data for AI to find those dependencies.
Kevin, you are literally reading my mind, because before you started telling about us about all of that, I literally just opened the skit-learn documentation page
I think
about
that's
the
where I
future
got from.
importance, and this is exactly what Kevin described. So we've got for any sort of algorithm, here. For any sort of algorithm, we can detect which feature, so which of the inputs is important to perform its job, right? So it is feature importance. And if that sort of alteration of the data that Kevin have described, which is kind of similar to x squared x1 squared I presented you a moment ago, kind of similar thing, right? Just the alteration of the input in some way that tells the model how to do the job. So according to that, if you take a look at those feature importances, and you can clearly see which of them are crucial for the model, for the algorithm to execute the task, and which can be easily skipped.
But does it really make some of the features obsolete, or do they actually carry some value and some weight in them, but we just don't observe it?
Yeah, in
out of the
that
gate?
in that diagram here, they still kinda matters. But if you see at this one, this is example where feature from 3 to 9 can be skipped.
I have a
And
nice example of a feature, I think.
6, 8 can be kinda looked into and analyzed from like mathematics perspective and analytics point of view, but
the rest of them present a statistical
irrelevance. Yeah.
Irrelevancy. I think I have a pretty nice example of a feature. What is a feature? Let's say you work at a God damn, what's the word for it? At a currency exchange point. Your work is to exchange currency, and people come to you and they give you cash. And your job, you are a newly trained model. Your job is to detect if a cash is fake or regular, right? So applying those features into this job, you could say that you can take the money and look at it under the UV light, right? This is one feature. And after teaching a model and comparing how it went with dataset, you see that, oh, this feature is actually very relevant. We should keep it. Then you can touch the money and you will see that, oh, fake money doesn't have the good feeling. And you teach the model, you check on data, you see that, oh, it's actually also kind of relevant. So we have two features now, two great features. And then you can lick the money. And turns out that after licking entire set of like cash, it doesn't do anything. It doesn't help detect anything. So from that, we can observe that this is irrelevant feature and we can stop using it. And
but
we can flick
I wouldn't lick money anyways.
Oh yeah. Just a terrible idea. But those will be basically the features, right? So what would be, to kind of going back to teaching your own model, what would be a feature in training a language model?
Oh, I will direct that question to you. I will direct that question to you, Kevin. What we are talking about today.
So what would be a feature for a language model? I'd say that, wait, so we first tokenize everything. And okay, I would say that the feature would be a mathematical correlation between a distance in vector space. Like distance between words, that would be first feature. Second,
that may be right.
Okay, so wait, aren't features just basically the temperature?
No.
These are not only.
This is a parameter of inference. Yeah.
Oh, right. So, goddamn, what would be the? Yes, this is what the training actually mean. So, what would be the feature? People in the chat, if you have ideas, feel free. But like, what would be a we over-explained what a feature is in training regular machine learning, but because I assume that LLMs also have features, right? Or they don't, because they are generative models.
Yeah, like what is the feature? What it represents that may be unique between the sample and the sample in terms of the text.
Something related to token recognition.
The text itself. It's your input. It's your unique input to the current situation of what you are talking about. Your query, your
So
document.
there are no like features.
I mean, if we go deeply, we can say that we can make vector representations that may be features for the classifying model.
So can we say that? Oh, right. Oh my God. Yes, yes, yes. So when we train models like that, we need to help them find the features, and based on those features, they will provide the task we ask them to. But with large language models, the language model are the features themselves. Basically, that
No,
model being trained.
features are the input here at this point. So underneath they are converted into tokens. They are represented into the representation space. It is executed in terms of the network flow, and also like the attention. So those connections between the tokens are being made, but that's in attention space, right? Yeah. So the thing is that our text, that huge stream of text that you have at the inference server, after you convert your beautiful API request into using chat template to a single string that goes into the model. Like those pieces of text, that string, that unique markers, like thing, like tool, like all of that, those are the features, the contents.
Oh, okay. Okay, see, the problem was that I looked at features as a set of actions a model can do on a data set in order to analyze it under different circumstances. But we don't need a model to modify text in any way. He can just look at text because text differs every time.
Yeah, exactly.
And the case is for a model to actually understand that this text contains some features in it that make the sentence offensive, for instance, or a compliment or whatever.
Yeah.
Okay. So I don't need to this.
So the text, the contents becomes.
But also, like, am I wrong in thinking that models who are tasked with detection work different than models tasked with generation? Because for generation, the text that is being implicitly a feature itself, it just triggers the model to generate something. So how it reacts to those features changes. But for other models, we need to train them to like detect things in the. Oh my God, that's a small switch, but actually very meaningful switch.
Yeah, very huge from like what it changes, right? Like,
But I really like to use metaphors.
mhm,
And now that you said that, it's I would say that let's use a metaphor of a dog.
mhm, mhm,
You can teach a dog to, I don't know, police dogs to find
mhm,
drugs, right?
mhm,
And you can teach them. You can teach them features. You can teach them what to react on to detect something.
mhm,
But this, like the fact that your dog can find and recognize drugs, it wouldn't
mhm,
also mean that it's trained. So this wouldn't exactly instantly be a good dog. Um, so the dog needs to also react to the voice, understand commands, and stuff like that.
mhm,
So by that, what we say, how we say it, those are the features, and it has to make an inference and react to those features that we present this time. Yeah, sorry, I got way too deep into trying to understand and process in my own way.
Yeah, but from the perspective of the metaphor, you are completely right.
Okay,
Yeah,
okay.
if we map those into this, yeah.
So,
You are right here.
but to answer what training is, let's just say that training is showing dataset to a model. After
Mhm,
it processes the dataset, we say good or we say bad, and then we show it different data and we repeat it until model is mostly right.
mhm.
There are a couple of topics for a different live stream, like this. I always forget how it's called, but it's a recall versus precision problem.
Yeah.
Yes. So, but this is
Mm.
for a different stream entirely. But
Yeah,
jumping
yeah, like
forward.
if your viewers would be interested, we would be able to prepare a session where we can literally from scratch, according to the input data, train the model and evaluate all of those
Oh
parameters.
my God, I'm
Yeah.
interested. If viewers can come on or they can't, I don't really care. I'm super interested about that. But continuing the journey, Piotr, please tell me, how does a model know it's wrong? Or does it?
So model itself does not.
Okay.
During the training process, you know, during the evaluation, you know, but the model itself, considering the fact that we've got inputs, we've got some function, a function that gets the input and provides the output, right? That's it. That's the model job to generate the
Mhm.
answer of yours. And in terms of Gen AI, of course, it can do a self improvement. So you've got a chain of thought, you've got a thinking process. So basically, it can try to generate the initial like answer and then reassure itself that that answer is really correct, corresponding to the input it has received.
So there is actually no real way to argue with a model, right? Because it always gonna treat the input as a matter of fact, as truth, inherent truth. So if we would have a conversation with a model and we would state out the like, no, you are being wrong right now, the model will assume that he is being wrong. But model at no point, unless there are some inter, I I really like when working with AI models, with agents inside Cursor, for instance. I really like to peek at thinking process. I
Mhm.
just love when those models are like obsessing and then screaming at
Mhm.
itself basically. And when I
Mhm.
see that thinking process, I can see myself in that being as well, like, oh no, I need to stop diving into this rabbit hole. I need to focus on the task, go back to the task. And those are actual things that I saw in thinking process of a model. It was
Mhm.
amazing to see. So model itself doesn't actually know that it's wrong. um, oh, by the way, in thinking,
Mhm.
um, are any other models triggered for thinking? I mean,
Mm.
if like if I ask model something, since as we said,
Mhm.
model can't know it's wrong and it treats all the inputs as a matter of fact, does thinking spin a different model that performs thinking with a task, for instance, check for factuality or any other things? Or does model process actually somehow by itself? Because I'm curious about how model can question itself
Mhm.
if it doesn't have an idea of it being wrong.
Yeah, so at this point, I will probably tell you something that will completely change your perception of model thinking. Model is trained to think. So if
So
you
it's
have
trained to
that,
second guess itself.
it is literally presented a thinking process.
Oh wow.
Yeah, so yeah, yeah, let that sink in. So the thing is that if you want the model to think, you send it at the input the think tag, it token,
Mhm.
thinking tag that becomes a thinking token, and later the model is basically like spinning up the thinking generation answer because it was trained that if you have the think in input, then you should first think, and how the model is thinking, that is actually how the model is trained. And if you want, for example, if you want to fine tune a model that was trained to think, you have to also show it the thinking and the answer in order
How
to
the hell can you gain dataset for thinking process?
you see you can also like kind of generate them. Of course, that depends from the architecture. There are many, there are plenty of architectures that are
Could you
implementing the thinking process completely uh, in completely else manner.
could you actually train, like, improve a model by training it on philosophy books? Because they basically teach you how to, like, the thinking process behind things.
I Yeah, and I will show you something that recently started resonating on X. So um, of course, I'm not like a fan of utilizing others model to create yours, but that's a very nice example of
That's distillation, right?
yeah, exactly. And this one, let me
It's
share my.
basically like creating your own um, service provider shop, but first you are like standing with binoculars and looking at the competition and
Mhm,
noting down what they're doing, and then pretending that, oh, we have our own thing.
mhm. Yeah, so you can switch the screen to mine. So what the people did, like the community is just amazing. On the Hugging Face, you can download a model which is like basically a Gemma 4 12 billion parameter base that was added the coding capabilities, mimicking the Composer 2.5 and also the Fable 5. And how they did that, they fine-tuned Gemma for 12 billion parameters on Python coding data, and the thing they did here, let me find, yeah, here. This is the most important part. So main set they did like how they influenced the whole model behavior, because Gemma 412 billion is basically a general purpose model, right? And they
Mhm.
changed the behavior into the coder model. How? They presented it Composer 2.5 chain of thought. So
Mhm.
you see model authored reasoning traces, teacher
Mhm.
solved each problem, and and the code was run against the task test, and the only passing solutions were kept. So, uh, so the reasoning you're learning from leads to code that actually works. So they, at scale, they generated Composer 2 and 5 solutions, and
Mhm.
solutions that were correct. They collected the thinking of Composer 2.5 and they put it into the training set with the answers. So with the proper chain of thought and the and proper answers. And if that Composer 2.5 got answers wrong, they handed it to Fable 5, right? To redo it and created a new
So it
chain of thought.
modified the chain of thought. Oh my
Yeah,
God, that's
yeah.
well. This isn't really full distillation. This is like paying for a tutor. It's tutoring, not a full distillation.
Ex-
It's tutoring.
and how that differs from training AI model? This is exactly it. You are tutoring the model utilizing the data. In that case, uh, it was done in the purpose of fine tuning. So they changed the behavior of general purpose model into the coding. Yeah. So, and also making it think completely different. Gemma 4 originally is thinking like, general average person. And in order to switch that into a software developer thinking mode, you have to present it software developer chain of thought.
In full, like in. You know what? In this live stream, I am Composer 2.5, you are the Fable 5. And I am actually saying out loud my metaphors and how I think about stuff, and then you confirm or deny and correct what I think. Thus, I'm learning from a person that knows better. And this is the same process, but with two human interfaces.
Yeah, we are the human interfaces here, Kevin.
Yeah. Yeah. So actually that's so, you know what? I was, well, more or less into AI stuff since all of it started, since GPT-3.
Mm-hmm.
And that's amazing how a lot of those changes and improvements and modifications are usually subtleties. They're very subtle. um, because you could look at this like, oh, so they used a model to train their model. This is stealing data set, this is distillation. But it's really not. It's kind of is. It's improving your data set using outputs, not really stealing the data. It's, I don't know, it's subtle, very subtle. But
Yeah, but you touch a really important problem, right? How to generate the thinking process at something that happens first time ever,
yeah, yeah.
and we
Also,
can see.
Infinity
Yeah.
confirmed that it's a nice explanation and says that he's Gamma 4. And in this, actually, what was the Gamma 4 in this? What would it be?
Uh, yeah, Gemma 4 was original general purpose model that they trained to become a coder here.
Oh, okay, okay. Oh,
It
okay.
was the base model that they fine tuned with composer and fable chain of thought and behavior.
Oh, okay, makes sense.
But Infinity, you are amazing. You are watching us and you are also chatting with us. Thank you for that.
Yeah, that I always love the interaction with people who are watching, because I tend to fall deep into just random conversations, and even, like, you know what, we're gonna have to do a part 2 of that, because we are right in the middle of all of the questions.
Oh my.
Yeah. So maybe let's do a last question,
Mhm.
which is kind of connected to, I think, what we are talking about right now.
Mhm.
Does AI memorize or understand?
Mm, remember,
And what is the wait? Actually, understand. And what is the difference?
yeah. So the most important question: which of those AI is really doing? You
I would
are, yeah.
say, I would say that there is no understanding for now. Current architectures do not understand anything. I would say that, what is the word in Polish? We have this nice word calling lanie wody.
Mm. Oh my God.
Because I feel like current models are just like students like spoken exam, verbal examination, that they memorized and remembered a lot of things. They don't understand it, but token by token, they speak, they talk, and they produce something that seems to make sense and sounds coherent. But at the end of the day, it's more memorized and you know what? Let me answer this like that. It inferences.
Mhm.
It performs inference. That's it. It
Uh,
memorizes partially, and then it does the inference.
we can kind of say that it does all of that. Depends from the point of view, right? But the thing is that within the data we've got patterns, right? Because we are not remembering all the data samples by heart. You remember that learning rate parameter during the
Mhm,
training
mhm.
demo? Yeah. So the thing that you always
Yeah,
use,
I
yeah.
I have a great example. What is the learning rate? At least I would say that the learning rate would be, if you would have to teach a dog how to recognize drugs,
Mhm.
the learning rate would be, you either hit the dog, or you spray it, or you scream at it. These are three different learning rates. And does it make sense?
Yeah, it makes it goes into how deeply the model is influenced by that sample, right?
Um, sorry, I got a little bit distracted because first, Infinity, a cache hit would be something different. We can explain it in a moment.
Mhm.
And Muhammad, we're gonna be talking about Eve framework next week.
Mhm.
I
Yeah,
think that's a topic
yeah.
for next week.
Uh, that's a very good question, and it requires a completely separate stream about that, because
Yeah.
that framework gives a lot of possibilities for developers, and using it is also very good from like developer experience.
Okay. So there's a huge topic. We'll cover that next week. And in full honesty, in full transparency, at this point right now, I have no clue what Eve framework is. But next week, I'll be joined by an amazing guy who also used to stream with me a couple of times, by Artur. And he knows a lot more about Eve. And we're going to be talking about that. And along with you, I'm going to be learning as well. So that's the fun part of those streams. I learn as well. That's why I ask so many questions. But going back to a question from Infinity, I mean, maybe not a question, but what would be a cache hit? Because cache hit is not really either memorization or understanding. It's what is a cache hit?
Yeah, it happens at the inference server inference kind of abstraction layer. So in terms of the conversation that you are having with the model, at the very beginning we had like a turn-based conversation. Remember that? Usually you send a system message, you send then a user message, you've got assistant message, you've got user message, you've got assistant message, and it grows, it grows, and also your data is growing and growing. And in order to continue the conversation, to continue the context, what you are talking about, it is growing and growing. And instead of reprocessing everything from scratch each time, if you are appending a small piece of information into the data, the beginning of it is usually got from cache.
So I quickly asked the model to show me this is how the conversation would look like, right?
Yeah, exactly.
System, user. Actually, let's say that it's okay. Yeah, I don't want to look more into the phone. I want to focus here. So this would be that.
Yeah, and assistant will be the answer of the model. And if you put another question, so follow-up question, or you say the model that you would like to do something else, you've got another user message. And at the inference level, there is no point in processing that beginning of conversation that was already processed, but it is in the aspect of the contents. But in the aspect of the context, it is taken into consideration when answering.
I would say that cache hits are actually kind of dangerous, because cache hits and cache overall in model inference is what is the main villain behind tunnel vision in models. At least that's how I see it. That's what I think about it. Because once a model gets hyper obsessed about something, it's going to be easy. Like, for instance, when I work with models and I ask a model to write a feature, right? He writes for me a small feature in the code, and it misunderstood my need, for instance, and the model thinks that something should work a certain way. So its cache is full of calculations that assume something that I didn't really want it. So in that scenario, it's much better and easier to just open a new chat and treat the situation as, oh, in this code is a bug that makes this work in that way.
And we can also, like, from that go smoothly to context poisoning topic.
Oh.
Yeah, we've got a plenty of things what's going on underneath and also during the conversation. So there's a lot of processes involved.
God damn it, Piotr. We already hit the 2 hours mark.
Yeah,
And
but
I think
if you allow me to quickly, very quickly answer that question, to come back to that last question and answer it.
Yes.
Yeah.
I'm sorry. Yeah.
So when you are presenting samples of data with a particular learning rate, you are training the model to detect the patterns from the data, and model in its waves, it is memorizing those patterns, and then when those patterns occur, the model kind of understands the patterns or what will happen next, what should happen next. So this is very important to cover all possible cases in the training data, because if you go into out of domain, it cannot detect that pattern, you see.
But this really needs some new special word? Because yes, model learns the correlation between words, it memorizes some things, but it does not inherently understand. So there needs to be some sort of a different word, something between learning and understanding. Because yes, model learns and it makes inference,
And then
but it doesn't understand.
it detects patterns and is able to navigate through those patterns.
God, I think we are just exactly describing inference. I think that's what it is.
Yeah.
Yeah. God damn it. I could really talk about this stuff for like another 5 hours, but
Me too. Really, me too.
what would you say that we can schedule a live stream for? Because I know that you also had some more stuff presented about actually teaching AI, but what you said before sounded really interesting about actually using tokenizers and datasets and actually teaching model on the go. So let's maybe do that. Not on this and not on next live stream because they're already planned, but I would really love for a part 2 of live stream with you, because
Me too. Me too.
As I said, we have still quite a bunch of questions for you. So let's finish. I think exactly in the middle, actually. So let's finish in the middle with memorize and understand, and on next stream we'll actually let's finish on that as a last thing, of course excluding things that are under under umbrella of the, what's the word, I keep blanking on words.
Yeah, from training perspective, yeah. So you are wasting your time, compute resources, therefore money, if you are training the model to do something that is not in your data.
But what did you hear about a situation that happened?
Of course, a lot of times I heard about the situations that someone tried to train a model that will do X, but the whole purpose of the data was about doing Y, and
So this would be basically like going back to the cash exchange. So it'd be like teaching the guy to recognize fakes and teaching him on monopoly money.
yeah, exactly.
Yeah, okay. I think I've heard also stuff about forgetting to set snapshots of models, and then at some point there's a crash or electricity goes off, and people lose quite a bunch of epochs, the wasted on trainings because there were no snapshots. There are also those weird situations of model overfitting to data and then suddenly dropping in quality. Can you imagine something like that happening with a model like GPT? You spend bazillions of monies training a model, and then suddenly it overfits to data and just like intellectually dies. God damn it.
You know what? As we are talking about like research and development field, I'm certainly sure that it happened several times.
Oh, but you mean like in production? Like they
No,
released models that.
I mean during training, like training. Yeah. So like in a target training, so sometimes sometimes it may fail. Of course, properly prepared training process will not allow for something like that to happen. But as you are experimenting and as you are, for example, getting the hyperparameters tuned, for example, yeah, you are experiencing a lot of crashes of the training process before you go to the proper path that succeeds.
Okay.
So you see, that's a trial and error, right?
No. I mean, I
But
would say
when
just
you,
like
but
we talked, preparing based on wrong features, spending some time teaching the model, but teaching the model to observe incorrect stuff. God damn it. Okay. Yeah. Piotr, let's finish here. So let me stop sharing the screen and put a slight background music for our outro. It's like a lo-fi.
Kevin, thank you very much for those questions. They were amazing.
Thank you very here actually. Oh, this is the same screen. Okay, Piotr, thank you for being here with me. I honestly was not expecting that I will have so much fun. God, there was such an interesting topic.
Yeah.
I hate when people just talk about, oh, you can feed this into AI and you can earn money. It's such an interesting, fun technology. Go like couple of layers lower into the roots of how it works. That's where the fun lives.
And remember how I began the whole stream, that right now we have a hardware and the possibilities to perform all of that.
Yeah, exactly. And I believe that at some point we're gonna hit the limit with hardware again. We're gonna optimize the heck out of software, and then we're gonna, most probably the next step will be quantum, right? Quantum technology for, like, imagine teaching AI on quantum computers. That's gonna be just the next level stuff. So yeah. So guys, Infinity will be there for part 2. I really hope so. We'll be waiting there for you. And says that also, good stream, guys. Thank you very much. I also believe that it was a very good stream. I learned a lot. It was super fun. So Piotr, thank you so much. And I'm very sorry for derailing conversation so many times, but when I get overexcited, I behave like a golden retriever, and I just jump over the place.
Those delays were needed, and they made that stream that fun. And it was also a pleasure for me. Thank you very much, Kevin.
Thank you as well, and I hope to see you. We'll plan it out. We'll inform everyone on access and stuff like that. So everyone, be welcomed on the next stream. In a week, next week, we're gonna be streaming with Artur, and we're gonna talk about Eve framework. So I will finally learn what that is, because I've heard it a couple of times already. So yeah, with that being said, Piotr, again, thank you so much for streaming with me today, for teaching me so many new cool things. Thank you to Infinity for being with us so actively. Thank you, Ryan, as well, for the same thing. And thank you, Ayman. I hope you stayed with us. And thank you, Mohammed, for asking about Eve, because this gave us a nice segue to promote a stream next week that will happen. But from now on, every Thursday, 17 CEST, which is Central Eastern something time, each week. And without
Central European summertime, if I'm correct, yeah.
So is there CEWT, like Central European Winter Time?
No, just Central Europe time. It is CIT and CIST. So summertime and without the word summer.
Oh, okay. Yeah, makes sense. Makes sense. Oh, right. So I'm gonna have to make a correction. Anyways, sorry. I think I need some rest, and I think I need some coffee. So again, Piotr, once again and last time, thank you so much for today's stream. Thank you all for being here with us. And now I'm gonna just gonna change the backstage to that's all. And guess that's all.
Thank you.
Bye,
Thank you all. It was a pleasure.
And see you next time.